Hello to my respected lecturers, Indian and my fellow friends. My name is Yeong from 2PISMP RPT2. Here, I'm going to share with you about my task for project products for course MTS 3352 Introductions to Mathematical Reasonings. Let's get started. According to ACUS in years 2020, solving mathematical problems has been one of the key points in research in mathematics education for several decades. One essential aspect of mathematics that is emphasized in both TIMSS and PISA is the ability to solve non-routine problems. In this point, students are encouraged to use the Poyas problem-solving methods to improve numeracy, problem-solving skills, logical reasoning, and critical thinking. First, non-routine problems. According to Nguyen and others in years 2020, the ability to tackle non-routine problems that cannot be solved with a known methods or formulas and require analysis and synthesis as well as creativity is becoming increasingly important in the 21st century. Besides that, according to Robinson in year 2016, non-routine problems have multiple solutions and solutions may differ among students. Specifically, non-routine problems encourage students to be flexible and adaptable in the problem-solving process, explore different approaches and perspectives, and promote a deeper understanding of mathematical concepts. Also, non-routine problems require attention, creativity, analytical thinking, and more cognitive efforts than routine problems. Next, in this coursework, I use symbolic representations to solve and explain my questions. According to Zhe in year 2023, mathematical representations is an instrument for students to grasp mathematical knowledge and ability. In mathematics, symbolic representations involve using symbols such as letters, numbers, and mathematical notations to represent mathematical objects, convey meanings, and express relationships. As examples, symbols like plus, minus, times, dividers, and equals represent basic mathematical operations, while variables such as s, y, and z indicate unknown quantities and placeholders. One of the strengths of symbolic representations is the ability to express complex mathematical ideas concisely, thereby improve readability and comprehension. My question is taken from TIMSS 2011's book grades Mathematics Concepts and Mathematics Items. The name of the question is Trading Cards. The topics I have chosen is based on the applications of reasonings in number and operations. The town fair has a booth where people could trade cards. One animal card is worth 2 garden cards. 2 animal cards are worth 3 sport cards. Some children went to the booth to trade cards. Brett had 8 garden cards to trade for sport cards. How many sport cards would he get? Let's start with an introduction to the Poyas problem-solving methods. According to guidance in year 2023, in George Poyas' words, How to Solve It, Poya provides 4 fundamental steps that serve as a compass for handling mathematical challenges. It consists of 4 key steps that includes understanding the problems, devising a plan, carrying out the plans, and reflecting on the solutions. The first stage of Poya problem-solving methods is to understand the problems. Depending on the questions, we are given a trading scenario where certain cards have different values. The trading ratios provided are 1 animal card for 2 garden cards and 2 animal cards for 3 sport cards. Brett has 8 garden cards and wants to trade them for sport cards. So, we need to identify how many sport cards Brett can get in exchange for his garden cards. Next, we need to devise a plan. This question is divided into several stages. We need to convert carton cards to animal cards, then animal cards to sport cards. First, work out how many animal cards Brett can get with his 8 carton cards. Then, work out how many sport cards Brett can get with his animal cards. So, I decided to use symbolic representations by using the ratios methods to solve these problems. Next, we carry out the plans. We have known that one animal's card is worth 2 carton cards and 2 animal cards are worth 3 sport cards. To solve these problems using the ratios methods, we will set our ratios to represent the exchange rates between the different types of cards. Then, we can use these ratios to find the numbers of sport cards Brett can get for his 8 carton cards. Okay, let us consider. S is the number of animals cards Brett can obtain. Y is the number of carton cards Brett has, which is 8, and Z is the number of sport cards Brett can obtain. Now, we set out the ratio based on the given information. First, ratio between animals card and cartons card is 1/2. Ratios between animals card and sport card is 2/3. Now, we are using these ratios to find the number of sport cards Brett can obtain. First, let us find how many animals cards Brett can get using the ratios between animals card and carton cards. S over Y is equals to 1/2. S is equals to 1/2 times Y. So S is equals to 1/2 times 8. Then S is equals to 4. So Brett can get 4 animals cards. Now let us find how many sport cards Brett can get using the ratios between animals card and sport cards. Z over S is equals to 3/2. Z is equals to 3/2 times S. Z is equals to 3/2 times 4. So Z is equals to 6. Therefore, Brett can get 6 sport cards. Therefore, using the ratios methods, we find that Brett can obtain 6 sport cards in exchange for his 8 carton cards. Lastly, it's important to look back and reflect. We can work out another way to prove whether the answer we got above is correct or not. For example, we can use a visual representation to clearly see the additions and distributions of cards in this problem. Table 1 shows Brett trades the carton cards to animals cards. From Table 1, Brett has 8 carton cards which can be represented by 1 plus 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 1 is equals to 8. He can trade cards for 4 times and each time with 2 carton cards for 1 animal's card. Thus, the total numbers of animals cards he trades for can be expressed as 1 plus 1 plus 1 plus 1 is equals to 4. From Table 2, he ends up with 4 animals cards in the first round of trading card. So for the second round of trading card, he is going to trade 4 animals cards for sport cards. This can be represented by 1 plus 1 plus 1 plus 1 is equals to 4. At this time, he can trade animals card twice, 2 animals cards for 3 sport cards each time. So the numbers of sport cards he finally gets can be represented by 1 plus 1 plus 1 plus 1 plus 1 plus 1 is equals to 6. Consequently, we found out that Brett can exchange 8 carton cards for 6 sport cards. So we can prove that the answer that we get in stage 3 is correct. This is the end of my representations. Thank you for watching. Bye!